All right, in this tutorial, we are going to go through how to build an auto-updating website that doesn't cost any money. What we're going to be doing is we're going to be grabbing data that exists on the internet and building a data visualization that updates every hour or every week or every month or every 2 days or whatever you want it to be. So a use case for this, and the reason why you'd usually do this, is there's some data that lives somewhere on the internet and you don't like how it's displayed. So for example, right here we have the most polluted major city rankings at iqair.com, and it has all the cities and it has, you know, the air quality index score and their followers and their rank and all this stuff. And you say to yourself, I could do this better. I could tell this story better. Now, oftentimes you won't be scraping from some random air quality website. You'll be pulling it from something like, the Department of Commerce, or you'll be pulling it from, the police department or some sort of government website or something like that where they make kind of an ugly visualization. Then you'll pull it somewhere onto your own website to make a better version of this. So this is what we're making here. Arguably, it is not better than the original version, but we'll be okay. We'll be okay. And so what we're going to do is we're going to build this so that it lives live on the internet and it auto updates every hour without us having to do anything. So there is a world where maybe we could sit there and once a week we could download the data from this website, build a little visualization, and update a web page. But that's just too much work, right? We are all very lazy people and we would like the machines to do the work for us. So that is our goal. Automatic updates that happen whenever you want them. Frequency could be as short as every 5 minutes or, once a month or anything like that. So here's what we're going to do. The first thing that has to happen in order for us to make this website here is we need to scrape the data off of this website. We're going to be doing that using a Python script we're going to write in Jupyter Notebook. This is the least important part of all of this. If you wanted to run this code in R, or you wanted to scrape with some other Python libraries, or you wanted to use command line tools or whatever else, however you want to get the data, it's not important how you get the data. We are just trying to snag this data. So number one, we are going to steal the data. It seems rude to say steal the data. Turn the website's data into a CSV of our own. In this case, we're going to scrape it. So how are we going to do that? Well, let's close this, head on over to this website. Now, when we inspect this isn't a scraping tutorial, but I am going to give you the biggest time saver that you'll ever encounter, potentially. So right here, we see this data is living inside of a table. Oftentimes, when you have data that is some sort of spreadsheet style data, it is displayed in the format of a table. If you are used to scraping with things like Beautiful Soup and requests, you can use these tools to scrape data from a table, but it can be a little bit painful. I'm going to show you another way to scrape data from a table that just uses pandas. Pandas is basically Excel for Python, shall we say. It allows you to work with tabular data really easily. So what we're going to do is we're going to run this code right here, and then we're going to say, hey pandas, please go out and read the HTML on this web page. Throw that web page in there, and we run it. It goes out there, it grabs some stuff, and it looks really, really ugly. If you have ever used pandas before, you would say, this is not what this is supposed to look like. I expect to see some beautiful, beautiful little summarized table underneath here, not this ugly, like monospace kind of deal. And I say, you're right, it's true. When you tell pandas to go read the HTML of a web page, you're saying, hey, go find all of the tables that exist on that web page and try to pull the information out of them. Note that it's not just one table, it's all the tables. So what I usually do is I say, go get all of the tables and then look at how many tables it is that we actually downloaded, that Pandas was able to find on the page. In this case, there's only one. So if I do tables 0, there we go. This is our beautiful, beautiful data frame. The only problem being, I don't really like these titles here. Like, why is major city, region city a bunch of missing data? And why is there also major city, country region .1 that is actually the city name and the country name? So usually what I'll do before I save it is I'll clean up the data a little bit. So we're going to save this as the variable df because that's always what you do. And it's time to clean. I'm going to look at the columns and I'm going to think of the ones I don't want. Major city, country, region, I do not want. So I am going to tell Pandas to drop it. df drop columns, and then tell it the one I want to drop. And then I'm going to rename this one here. So I'm going to say, did I run that already? I think I did. So I'm going to say, hey Pandas, df dot rename. So rename this column to be just location. That should be fine. And then let's look at it. So yeah, that looks pretty good. We probably should have called this location with a capital L, but here, let's do that. I'll make this a capital L. I'm actually going to go back up here, read the table again, grab the first table again, look at the columns, drop that, rename that, and now life is good. Our final step after we've cleaned it up is we are going to save it to a CSV. I'm going to call this airquality.csv, and I have to say index equals false because otherwise it's going to save this weird little thing here. Save it. Let's take a look. We have, this is from when I tried to record it before, measurements.csv, gonna delete that. Airquality.csv, here we go. Looks pretty good. In an ideal world, we probably would have cleaned up this followers column a little bit, but I'm not gonna clean it up because we're not actually gonna use it. So this looks good. Looks like we saved it correctly. Perfect. All right, next step. We have turned the website's data into a CSV of our own. So we used pd read HTML to find all of the tables, grab the first table as our data, let's say table elements, grab the first table as our data, cleaned it up a bit, and saved it as airquality.csv. Now, our next step is make that update automatically, which is going to take us a couple steps. The first step is going to be make it a GitHub repository. Not so hard. Now, if you are someone who knows how to use Git, and you use Git on the command line, you are going to laugh out loud as the next step when I open GitHub Desktop. So I think GitHub Desktop is great because it's harder to screw things up than it is when you're using command line Git. So it's what I like to teach. So what we're going to do is, in order to get our data up on the internet and get our script up on the internet, we are going to say File, Add Local Repository, Choose, and I'm going to browse to where my data is. My data is in Auto Update Website. I can see my CSV, my Markdown, and my IPyNB. I'm going to click Open, and then I'm going to click this Create a Repository link. Now, I did not accidentally go to Add Local Repository. I think it is the best way to automatically fill in all of the details under Create a Repository without screwing things up. So I'm going to say, yes, I'm so sorry. I did want to create a repository. It gives me all these options. I'm going to call this Bad Air Cities. I am going to, sure, I'll create a git ignore, even though it won't do really what I want it to do. I already have a README. That seems good to me. Create repository. And now I'm just going to click all of the buttons until bad air cities. Don't make it private. All the blue buttons until all the blue buttons go away. All right, no more blue buttons. Now we can click view on GitHub. Ta-da! View on GitHub, amazing. The fact that this DS store file is here is awful, but we'll survive, we'll be okay. We can see our Python script made it up, our README down here, as well as airquality.csv. So what we need to do now is we need to make it so this file, this air quality file, is updated every single hour. How is this air quality CSV file get updated? AQI updater needs to be run. So you have to make sure that whatever your Python script is, or however you're updating your CSV file, you have to make sure that this is up in the same GitHub repository. I guess in theory it could be in a different one, but you want it to be in the same GitHub repository. And now we need to say, hey GitHub, I want you to run this file for me. And then whenever it changes air quality CSV, make sure to save that into the repo. The way we're going to do that is, let's see, make it a GitHub repository, turn on GitHub Actions, and set it up. So GitHub Actions, instead of us running our AQI updater script on our own machine every 5 minutes or every hour or every day or once a month or whatever, GitHub / our good friends Microsoft will let you use their servers up in the cloud to do all of that for you. So, you know, there are bad things about depending upon free services that exist out there, but it's so much easier than running it on our own computers every 5 minutes in order to update, or every hour or whatever. I like to sleep. So we are going to click Actions, and we are going to click Simple Workflow. Now, the problem with saying Simple Workflow is it's going to say, this is the setup that we think you should have about how to automatically run things in your repository every hour, every 5 minutes, once a month. Usually, this stuff is used for CI, is continuous integration. Basically, whenever you make a change in your repo, it will run this code that is a bunch of tests to make sure that it passes all the tests. We don't have tests. We don't want to do these things. All we care about is just updating our CSV file. So what I could do is make you read all of this. I could make you dig around and understand what everything is, but that's not what we're going to do. What we're going to do is we're going to steal code from one of my repositories that already updates frequently. So if I go to this URL, which I'm going to put down as a link below, this is an example of what the configuration of a GitHub Actions might be. And we'll go through and look at it. We're going to copy all of this code, and we are going to delete every single thing that they gave us, and we're going to paste in ours instead. Could we have manually made this file on our own? Yes, but because it has to live in a folder that's called .github, and then workflows inside of that, and then blank.yaml, or whatever you want to call it. Let's call this update.yaml. Doesn't matter what you call it. It's just hard to get it in the right place, I find, which is why I like to use the create one using the clicking interface sort of fashion. So we can call this whatever we want. Right now it's called daily because it does a daily update. It's called update here. I'll just call it update here. Those don't have to match though. Sometimes GitHub changes the way that this file needs to be formatted in order to set up the actions. And because I did not have this line in some of my old repos, it was just breaking things left and right. So if you ever get a permissions error, it is probably as a result of this line here. This next step down here where it says on, this is setting up how you are able to run your script. In this case, workflow dispatch, means if I click around on the interface on github.com, I can run it. And then schedule and cron says, here's how often I want it to run. Now, these cron codes here are difficult to understand. And usually I would say, oh, Google like cron setup example. Let's see. Yeah. So I'd click this and then I would read through this and read, and it would be, you know, it would be fine, I guess, maybe. But here we go. One thing that's really, really nice about using this tool here, instead of trying to create this file on your own machine, is it tells you exactly what you're looking at. So right here, this means runs at 4 a.m. every single day. If I change this to, let's say 11, it now is going to be running at 11 a.m. every single day. Now, if you're trying to figure out how to, let's say, make something run every hour, what I'd recommend doing is, here, if I can pull this on over, here we go. So I think asking ChatGPT is honestly the best way to do it. Like, yes, I do know how to do this, and you can memorize the syntax. It's not actually that complicated. But run something, cron syntax for running something every hour. Now, the delightful thing about GPT is it will explain it to you instead of just giving you the answer. And so if you wanted to tweak it, and I could say, I mean every 4 hours, it will say, oh, every 4 hours, here's what you do. Here's what you do instead. So any sort of schedule you want it to be on, whether it is every Monday or every Tuesday at 4 p.m. or something like that. Watch, every Tuesday at 4 p.m. Look at that. It's amazing. So we are going to use the, let's see, this is every 4 hours. I'm going to make it every 2 hours because why not? And now here's what's happening. It's setting up a virtual machine. It's copying the code from this repository in order to run it. It's setting up a Python to be able to run that Jupyter notebook that we made. It's making sure it's Python 3.10. Right here, this is installing all of the necessary packages. I will make another video about how to debug when you are working in GitHub Actions. But basically, every single library that you end up using inside of here, we're using requests, Beautiful Soup, Pandas, and Jupyter, needs to be pip installed here. So Jupyter, Pandas, requests, Beautiful Soup, and LXML and HTML5 lib make the scraping more likely to work better. Now, every single one of these little pieces down here has two different bits. One is name and one is run. Name is the description just for you when you're debugging or for you to explain what is happening at this step. We're installing the packages. How do we install the packages? We run pip install blah, 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 blah. Then, in order to scrape today's data, this long line of code right here runs a notebook called scraper.ipynb. Now, the most important thing is that you make sure your file name matches the file name that's right here. I guarantee you're going to copy and paste this. You're going to be excited. You're going to get ahead of yourself, and you're not going to remember to change it. If we look at our Bad Air Cities repo, ours is called aqi_updater.ipynb. So I'm going to change this to be aqi_updater.ipynb. Then this final section right here, I just cut and pasted this, years ago, and it still always works. If there is a change to your measurement CSV, your air quality CSV file, it is going to automatically push it up and update. So I'm going to commit changes up on the top right-hand corner, create update.yaml, sounds great, commit changes, go. Here's the file, nice little file here. What I want to do now is test it out. I could wait 2 hours to see when it runs every other hour or every hour divisible by 2. But instead, I'm going to go to Actions, and then I'm going to click Update on the left-hand side here. And then I'm going to click Run Workflow, and then Run Workflow here. This is the most complicated thing with so many clicks, but again, you click Actions, you click Update, then you click Run Workflow, and then finally Run Workflow right here. Workflow run was successfully requested up at the top, and now it's going to take a little bit of time and say, hey, please run this up in the cloud for free. Eventually it will show up with this little yellow thing. You can click into it. Why not? Oh, it's still called daily. I forgot to change it. Installing the packages, installing the packages, installing the packages. It might take a little while to install those packages, but 30 seconds isn't the worst thing in the world. Now we're scraping the data. If it has all gray checks here or a green check over here, that means it was successful. So if we look right here, if we click code to see all of the code in our repository, we can now see our airquality.csv file latest update. Right then, it just got committed. The most recent stuff that we pushed up, the code that we wrote, was 11 minutes ago. And this one is perfectly brand new. So if we click through, we can see it. Amazing, incredible. And that is all you need to do in order to have it automatically updating something in your repository. So let's go back to VS Code, make it update automatically, turn on GitHub Actions. We'll say set up your YAML file. Be sure to make sure your notebook name matches. So obviously that's the thing that you're going to mess up. All right, wonderful. Next step, instead of just having this CSV file sit here and be sad and lonely, we need to make a website. Now, the way to make a website is to create a file that is called index.html. So I'm going to click right here and I'm going to say index.html. Now, there is a world in which maybe, you know how all of this stuff works, and you know HTML, and you know all these things, but I'm A, congratulations if you do. B, if you don't, I don't want this to be an HTML tutorial. So what we're going to do is just cut and paste the code, some sample code that I had before. And this sample code makes a website that looks like this. The one thing that we need to change about this website is just, here is where our graphic will go. This is the place that we need to edit some things on in order to make our website, actually useful. Now, there are a lot more steps, but before we step into those steps, I just want to make sure we can push this web page to the internet. So I have created index.html inside of my folder that has my air quality CSV, it has my notebook, it has my README, it has all of my files. So now, GitHub Desktop, it says, hey, you made a new file, you updated your README, let's save that. I'm going to say added the index.html because who cares about the README update. I'm going to make a commit, and now something crazy is going to happen. Usually when I click this button, it sends all of my updates up to GitHub. So if I push this button, it should say, hey, here's a new file, index.html. But when I click it, it's going to yell at me. It's going to say, no, there's newer stuff up there on the cloud. Now, this is something that's very important when dealing with GitHub Actions and automatic scrapers. They are scraping all of the time. They are scraping again and again and again and again. And the code that exists on GitHub is newer, has newer CSV file than the stuff that exists on your computer. So you will often have these things that look like error messages, but all they mean is, hey, can we download that updated CSV file and pull it onto your computer? And you say, yeah, fetch it. I'd love for that to happen. Yeah, pull that new stuff up. It'll be great. And now, if we look on our computer, we see that we now have our update.yaml file. We have our updated air quality CSV file. Not that we can tell that it's actually updated. But all of those files have been copied to our machine by fetching and pulling. Now, in order to send our index file up that we already added, we click push origin. That will shove it on up. And then if I have it open over here, but we could also click view on GitHub, and then we can see, great, we have our index, we have our CSVs, we have all of this stuff. So let me add to my README, make a website. So create an index.html, add it to your repo and push it, no, I'll do that, and push it up to GitHub. Great. Now, when we look at a web page, we can look at a web page on, let's say, our own computer. If I open up index.html, we can see it. It looks like this, but this just lives on our own computer. We cannot share this with other people. Once we push it up to GitHub, we still can't automatically share it with other people. If they go to look at index.html, they just see the source code of index.html. They're not seeing the beautiful website that we want this to be. In order to turn this into a beautiful website that exists on the internet, like any other website, we are going to go to Settings, and on the left-hand side, we are going to find Pages. GitHub Pages is GitHub's web hosting platform. It's pretty good, pretty easy to use. It works really well when we are dealing with GitHub Actions because it just keeps everything very, very close. Unfortunately, at this part, we just have to click a bunch of buttons whether or not we understand what they mean. So under source, if you click that, it says you can do this with GitHub Actions or you can deploy from a branch. Now, we're just going to click deploy from a branch, that classic Pages experience, whatever that means, we're just going to leave it. Are we using a framework? Do we need to customize our build process? No. So even though we are using GitHub Actions, we're not using GitHub Actions to put together our page. So make sure that under source, it says deploy from a branch. Next up, under branch, it says GitHub Pages is currently disabled. Select a source to enable GitHub Pages for this repository. Now, the best thing about this is for each of these options, there's really only one thing that works. So if we click none over here for the branch, we have to click main. Yours might say master, depending upon how your Git is set up, but just click the first one there. And now it says, do you want to take the files that are inside of the root, which is just the /, or do you have a subdirectory that's called docs? And you say, well, if I look at all my code, I definitely don't have a subdirectory called docs, so don't pick the one that says docs. Pick the default one that just says root. Then click save. After you click save, up at the top it says GitHub Pages source saved. Now, it used to have a big, nice box up at the top that said, hey, we're working hard at putting this up on GitHub Pages. For some reason, they got rid of it, but if you go into Actions or something like that, you can see there's a magic thing happening here, where even though we didn't say use GitHub Actions, this is GitHub trying to put our web page together, trying to host it onto the internet. We can't visit our page until this gets the little green checkbox. I don't think it will ever throw an error. I don't think I've ever seen it have an error, but it does just mean we can't visit our website until it actually works. There we go. We got our green check. And if we go back to our GitHub Pages by going to settings and then pages, there is now a banner that says your site is live at this URL. If we visit this site, we can now see our index.html not just on our computer, where if I double click it, it says user Soma development videos, blah, blah, blah. This, not everyone can see. But this website right here, we could send to all of our friends and we can say, here's a URL, it's real, it's on the internet, everyone look at it. And they'll say, why don't you have a graphic there? And we'll say, that's the next step. So make a website, create an index.html, add it to your repo, push it up to GitHub, turn on GitHub pages by clicking many buttons, and then make sure your index.html works by visiting your page. Now, you could have just hung out on pages and just kept hitting refresh and refresh and refresh instead of going to look at actions like we did in order to see this happen. But whatever one works, once it is finally published, you will be able to see it at that URL. Notice it's username.github.io/ whatever the name of the repository is. So if you've named your repository badly, I would recommend going to the general tab and then renaming your repository so it can have a nice name. All right, next step. We have made our website. We need to make a visualization for our web page. Now we're going to use Datawrapper. Datawrapper is, as a data journalist, Datawrapper is what I love. It is what is used by many, many newsrooms for many, many things. Other folks out there might use tools like Flourish or stuff like that. Probably works the same way, maybe even Tableau. But for us, we are going to stick with Datawrapper. Just know that you can probably transfer this into other workflows. All right, so right now we have this URL here that shows our index.html. We'll hold off on this for a second. Let's go to datawrapper.de, and we're going to say, I would love to make a new visualization. So I'm going to click dashboard. I'm already signed in, and I'm going to say create new. And I'm going to pick table because the display that I want it to display is table-like. You could do chart, you could do map. The workflow is exactly the same no matter what you pick. So I'm going to pick table. And here's the part where things pay attention to-ish. Now, normally, when you build a graphic with Datawrapper or any similar tool, you are going to upload your Excel or CSV file. So I could click this link, and then I could say, oh, I want to add air quality CSV. Don't do it. Don't do it. It's a trick. Don't do it. If we do this, it is never going to update again in its entire life. What we're going to do instead is we're going to click link external data. So this says, hey, there's a CSV file somewhere out there on the internet that I would like for you to pull the data from. Now, in an ideal world, we could just point this at this website and say, hey, steal the data from this website. But this is why we wrote a scraper. This is why we wrote something that saved this file to CSV. And then we pushed it up into a GitHub repository. Because now, in the same way that when we visit this page, this is actually printing out index.html. We can also say, instead of looking at index.html, what if instead we look at airquality.csv? If I copy and paste this, if I try to do it in Chrome, it just downloads the file, which, I guess that's nice. But what we want to do is push it right here. So we're going to say, this is the file that we would like for you to pull data from. Now, the reason why this works and why this is good is because our GitHub repo is now every 2 hours running this Jupyter notebook that updates this air quality CSV file. And now, as long as Datawrapper is continually getting the new version of airquality.csv, it is going to be displaying the most recent data. So if you look down here, it says the data will be updated in increasing intervals depending upon when you last published the chart. So less than 24 hours ago, if we just recently made this chart, then it'll update every minute. But for anything after that, it is going to be updating every single hour instead. You could also try to serve the data file directly, but I'm going to be honest, your server probably has CORS problems, so I wouldn't recommend it. So we're going to stick with this. I'm going to click proceed. It's going to say, here's what our data looks like. We think that rank and AQI US are numbers, and I say yes. And it says location is text and followers is text, and I say, sounds great. Proceed. Now I need to build what my visual is going to look like. If I go to check and describe, actually, I think I can remove some of these. Hide column from visualization. We'll do that a different way. I'm going to go to visualize. I am going to turn off pagination so that we get this nice show 89 more here. I could also just make it show 100 at once, but the problem with that is that there are then 9 more because this list is 109 long. So maybe I'll make it something like 60 at a time. I'm going to make it searchable, so I get a little search here. I'm going to show ranks because I think that this is a little bit more attractive than this rank here. I'm going to make the layout a little bit tighter. Because I have rank here, I'm going to get rid of this rank column by removing it on both desktop and mobile. I'm going to get rid of the followers column. For the AQI column, I am going to reformat it. I'm going to color cells. Nope. I'm going to show as heat map. And you say, wow, look at that. And I say, no, that's not what we want. We're going to customize it. The heat map starts from smaller values are good and bigger values are bad. So we could use this. I'm going to say make this steps. And you say, what are the steps? And I say, I have them right here. 0 to 50, 51 to 100, 101 to 150, 151 to 200. So, okay, I am going to make custom steps. We have, I think, 1, 2, 3, 4, 5, 6 different steps. So 0 to 50, 50 to 100, 100 to 150, 150 to 200, 200 to 300. Yeah. That looks pretty good to me. Anything else? Anything else? So I'm going to get rid of the title because there is already a title on our page right here. I am going to cite where we stole the data from. Our data source is IQAir. Jonathan Soma is the person who made it. Alternative description for screen readers. So this is a beautiful, beautiful graphic showing the top, showing 109 major cities and the quality of their air as a table. Several options here. What do we like? Embed links. I don't care. I don't care. This all seems great. Automatic dark mode. I love a good automatic dark mode, but we'll leave it. And now we get to publish it. Look at this graphic. This graphic seems pretty nice. Publish now. When I click publish now, it goes out onto the internet. It gives us several options for sharing and embedding. The first set is just a link. We do not just want the link. What we are looking for is embed code for our visualization. Now, I've always used responsive iframe. I don't know what embed with script does, but it's only compatible with 95% of browsers, and this one's compatible with 99% of browsers. So we're going to stick to responsive iframe. Responsive iframe allows it to get bigger and smaller based on the size of the screen, whereas iframe will not get bigger and smaller based on the size of the screen. So I'm going to click copy. Then I'm going to go to my index.html. I'm going to scroll down. Here's where a graphic will go. I will paste it right in there. Now, it's not going to do me any good if I just have this sitting on my own computer. What I really want, I guess I could look at it on my own computer. I don't think it's going to work if I just open it here. Oh, I guess it does. Wonderful. So, do we think this looks good? I say it looks good. I think that 59 more is probably fine. So let's push it up to the internet. In order to push it up to the internet, I go back to GitHub Desktop. It says, you made some changes. I say, yeah. I added the visualization. Commit to main, push origin, pushes it up onto the internet. Now when I refresh here, we can see that added the visualization was just pushed up. Now, if we quickly go to our website and we refresh, we do not see our graphic. We simply see here's where the graphic will go. But that's just because it might take a little while in order for the website to update. In order to check and see how long it's taking for the website to update, or if it is actually working on it, remember how we went to GitHub Actions before and we saw the pages build and deployment? You could just hang out here and sit here and wait while it loads and loads and loads. The thing that we can do in the meantime, just to clean up our repo a little bit, is we can go to About. We can click the little gear next to it. We can add our website URL, or we can just click Use Your GitHub Pages website. I'm going to call this an auto-updating website of major cities air quality index. There we go. So it threw me a link right there. Let's look at the actions. Successfully published it. So now I'll look at this and force refresh. A force refresh holds down the shift key. So if you hold down shift and then click refresh, there we go. There's our beautiful, beautiful auto updating website. And the one thing, here's one thing I'm going to tell you that I don't actually know the answer to. When we were on the Datawrapper website, it said, when we had this graphic here, let's see, for the upload data. Yeah, it said it's only, I wonder if after 30 days it just never updates again. I'm not sure if that's true. I should probably research that. But for now, we'll just say that it's true because I'm pretty sure it's true, but we'll find out in the future. So there we go. That is our wonderful, incredible auto updating website. Let's add our final few steps on here. Make a visualization. We're going to use Datawrapper. Make sure we're linking to our data, not uploading it. We want to use the responsive iframe version of embedding and add it to our, then we're going to update our web page, add the embed code to our index.html, push it on up to GitHub Pages, wait for GitHub Actions to finish deploying our web page. 6. It's time to party. I think that was great. I think we did a great job. There are hundreds of other ways that we could be updating our data, or hundreds of other ways that we could be dealing with our website. But this is a pretty basic workflow for when you have data, full data you want to pull down from the internet. It's slightly different if it is something where you would like to get data over time. So let's say what we wanted to do was just pull down this number right here every hour and save it to a CSV. Because even though this website does have the readings over time, maybe what we really wanted, maybe, this happens a lot with government data where they just publish the current situation. If over time you are just pulling down this every hour, adding it to your CSV, adding it to your CSV, adding it to your CSV, after a couple months, we are going to have hundreds of readings over time that we can put on a graph. Whereas what we were doing this time was just copying all of this data, and when we do that to CSV, we obliterate everything that was there before. So yeah, congratulations, you all are geniuses, and let me know if you make a website like this. Drop it in the link below. Comments below. You know what I mean.